We've been fooled by the sun for 4.6 billion years. It isn't actually the oldest object in the solar system. Long before the sun ignited, Jupiter had already grown into a gravitational giant in terms of seniority. It established itself before the sun did. Since childhood, we've been taught that the sun formed first, ignited nuclear fusion to become a star, and only then did the surrounding dust gradually gather to form the 8 planets. The sun is the unquestioned parent of the solar system, and all the planets came after it. But the latest planetary isotope research has completely overturned that sequence. The solar system's story was never one where the eldest was born first and the younger ones followed. Instead, the eldest formed first, and only later did the second ignite itself. To understand who the eldest really is, we first need to look at the true timeline of the solar system's birth. About 4.6 billion years ago, a massive molecular cloud began collapsing under gravity. More and more material gathered in its densest central region, forming a protostar, the embryo of the sun. Pay attention. At this stage, the sun was not yet a true star. The temperature and pressure inside it had not yet reached the threshold for hydrogen fusion. It only emitted a dim reddish glow from the heat produced by gravitational contraction. Simply put, it was a dark red fireball that hadn't fully matured yet. From this embryonic stage to igniting stable nuclear fusion and becoming a true star, the sun took a full 50 million years. Surrounding this fiery sphere was a circular disk made of gas and dust, which was the birthplace of all the planets. But from the very beginning, the birth of planets was a race against time. As the central protostar gradually became hotter, the powerful stellar winds it released would, within 1 to 10 million years, completely blow away all the gas in the protoplanetary disk. What does this mean? Gas giant planets like Jupiter had to complete most of their growth before the gas disappeared. If they were even a little too slow, once the gas was gone, they could never grow any larger. At best, they could only become rocky planets like Earth. That's why Jupiter was not only born extremely early. Its core had already fully formed, while the sun was still an undeveloped infant. At this point, you're probably wondering, how can scientists be so certain about something that happened 4.6 billion years ago? It's not as if they traveled back in time to witness it. The strongest evidence isn't found on Jupiter. It's found in meteorites that fell to Earth. They are the equivalent of archaeological DNA evidence from the solar system. They cannot lie. Scientists analyzed ancient meteorites collected from all over the world. They performed extremely high-precision molybdenum and tungsten isotope analyses on them. The results revealed an extremely unusual phenomenon. The meteorites from the early solar system were clearly divided into 2 distinct families. One group consisted of carbonaceous meteorites from the outer solar system. The other group consisted of non-carbonaceous meteorites from the inner solar system. Their isotopic signatures were completely different. It was as if they belonged to 2 completely unrelated families. Even more astonishing, during the extremely early stage, just 1 to 3 million years after the solar system was born, these 2 types of material had never mixed with each other at all. Think about it. The early solar nebula was rotating violently, filled with turbulent gas. What could possibly exist within the dust disk that could act like an invisible wall, completely separating the material in the inner and outer regions for millions of years? There is only one answer. Just 1 million years after the solar system was born, at a distance of 3 astronomical units from the sun, an object with an enormous gravitational pull had already appeared. Its gravity carved a wide gap in the protoplanetary disk. It was like an impassable moat. It completely blocked the exchange of material between the inner and outer solar system. That object was the newly formed solid core of Jupiter. At this point, the entire chain of evidence was complete. While the sun was still in its embryonic stage, Jupiter's core had already grown to 20 times the mass of Earth. It had firmly become the second strongest source of gravity in the solar system. It was the true firstborn of the solar system. You could even say it was a brother that helped create the solar system alongside the sun. You think growing a core 20 times the mass of Earth in just 1 million years is unbelievable enough. In the traditional theory of planet formation, planets grow through collisions and accretion between rocks. Even tens of millions of years would not be enough to build such a massive core. The reason Jupiter grew so quickly was an almost unfair growth mechanism, Pebble accretion. Simply put, it was like using a cheat code to consume material at an incredible rate. In the early protoplanetary disk, besides large rocks, countless pebbles ranging from a few centimeters to a few decimeters drifted through space. They were small fragments formed from condensed ice and dust. Because of gas drag, these small fragments continuously slowed down as they moved. They slowly spiraled inward toward the sun. When Jupiter's initial core grew to about the size of the moon, its gravity became strong enough to efficiently capture these passing pebbles. Unlike large meteorites that tend to bounce away after collisions, these small fragments were slowed by the surrounding gas. They flowed smoothly into Jupiter's core like running water. Almost no material was wasted. By relying on this highly efficient growth process, Jupiter's core, in just 1 million years, rapidly expanded to the critical mass of 20 Earth masses. Once it crossed this critical threshold, an even more dramatic phase of runaway gas accretion began. Jupiter's enormous gravity began swallowing the surrounding hydrogen and helium. Its mass increased exponentially. It eventually grew into the planet we see today, a giant gas planet with a mass 318 times that of Earth. Meanwhile, our sun had not even truly ignited IT had not even reached the threshold of becoming a true star. As the solar system's earliest formed giant, and its largest elder brother, Jupiter, did not remain where it was. Its early movements almost tore the entire inner solar system apart. They also directly determined the fate of Earth. This is the most dramatic hypothesis in planetary science, the Grand Tack Hypothesis. According to hydrodynamic simulations, after Jupiter formed, its gravitational interaction with the remaining gas around it caused it to slowly migrate toward the inner solar system. This giant planet pushed its way inward, reaching what is now the orbit of Mars, only 1.5 astronomical units from the Sun. Its enormous gravity acted like a giant mixer, violently stirring the countless rocks and planetesimals in the inner solar system. Many scientists believe, before Jupiter migrated inward, several super-Earths were forming in the inner solar system. This is very common in other planetary systems. Rocky planets several times larger than Earth are extremely common, but Jupiter's arrival triggered a gravitational catastrophe. The orbits of these early super-Earths became chaotic, and they collided with one another, breaking into fragments. Some were even swallowed directly by the Sun, just as Jupiter was about to completely clear out the inner solar system. Its younger brother, Saturn, had also grown up. Saturn's gravity pulled strongly on Jupiter from behind. The two giant planets entered an extremely rare orbital resonance. Under Saturn's gravitational pull, Jupiter miraculously reversed its direction. It then slowly migrated outward again, returning to its present orbit at 5.2 astronomical units. Jupiter's journey inward and outward was like a giant broom. It swept away the excess material in the inner solar system, while sending large numbers of ancient water-rich asteroids into the inner orbits. In the end, it left Earth with a clean and stable orbit, along with just the right amount of material, enough to form a habitable planet with a suitable mass and liquid water. It can be said that without Jupiter's dramatic actions in its early history, if it had never turned around, the inner solar system today would either contain a few barren super-Earths, or nothing more than a vast field of rocky debris. Our blue planet would never have existed, and neither would human civilization.